Good morning, dear students. So, we are discussing the topic coordination chemistry, right? Coordination compounds. So, in our first class, so what all things we have discussed? Yes. Okay. So, let us start. So, what all things we have discussed? So, we have discussed about what are coordination compounds, right? What are coordination compounds? So, these are the special class of compounds in which metal atoms, right, they are bounded by the number of anions or neutral molecules. These anions or the neutral molecules, they are called as what? They are called as ligands, right? So they are termed as coordination compounds, or they are termed as complex compounds, right? So this is the way the your metal and the ligands are arranged. The metal and the ligand, the bond which is present between the metal and the ligand, it is called as the dative bond or the coordinate covalent bond. Okay. Then, based on the nature of this compounds, okay, so that is the nature. So these are termed as the addition compounds, right? So these, what are addition compounds? So we have discussed these all things, right? The addition compound, based on the addition compounds. Uh, okay, so when two or more compounds are mixed in a fixed psychometric ratio, so they form new crystalline compound, and these are termed as addition compound. Now these addition compounds, these are of two types, okay? Double salts and the complex salts. Now what is double salts? So addition compounds, when you add it in water, they will dissociate into simple ions. So these are the double salts. So we have seen the examples, carnallite, more salt, okay, and potash alum. So please remember the molecular formula of potash, alum, and more salt. Okay, very important. And then what are complex compounds? So complex compounds, so these are also the addition compounds, but when we add it in water, it will not dissociate into simple ions. Okay, but they will produce complex ions itself. So this is the difference between your double salt and coordination compound. So now, so when see here, this is example which is given for the your double salt. So this is your potash alum. Okay, K2SO4 plus yes, dot Al2SO4 trice dot 12H2O. Okay, so this is potash alum. So potash alum, when you add it in water, it will give you simple ions 2K plus, 2Al plus 2, 4SO4 minus 2, and 24H2. So like this, they will give simple ions. But when we take a coordination compound, suppose this is a coordination compound, that is potassium ferrocyanide, that is K4FeCN6. So that when you add it in water, it will not give you 4K plus and 6Cn minus, but instead it will give you 4K plus and FeCN6 minus 4. So this is the complex ion which is retained, right? So so this is a main difference. So double salts, when you add it in water, it will give you simple ions, but complex compounds, when you add it in water, it will not dissociate into simple ions, but it will dissociate into complex. It will remain as complex ions itself. Okay. So these things we have discussed. Then we have discussed some of the important terms which we are going to use in the coordination compound. That is your coordination entity. Okay. Coordination entity. Then we have discussed about the central atom. What is a central atom? Then we have discussed about the ligands, right? So what are the ligands, students? So let us start with the ligands. Yes. So the molecules or the ions which are coordinated to the central metal atom or the ion is called as what? They are called as, they are termed as ligands. So like this. So metal will be in the center and the ligands will be present. Okay, they are surrounded by this metal. So these are bounded. Okay, so these are bonded through a bond. So these are metal, these ions or the molecules. Okay, they are termed as what? ligands. Okay. Now here is an example which we had seen. If K4FeCN6 is there, so which is the ligand? That is cyano group, your CN6. So there are six cyanide group. Okay, and the central metal is your Fe plus 2. Okay, and Cn minus are all your ligands. So your ligand can be a negative charge, positive charge, or they can be a neutral molecules. Okay. So ligands, they are basically Lewis bases. What Lewis bases? It has a tendency to give electrons. Okay. So they act as a donor atom. Ligands, they act as a donor. So they have a tendency to give electrons. And central metal atom is a Lewis acid. What it will do? It will accept electrons. Okay. So these things you need to remember. Then we had started with the classification, that is a type of ligands. So first was mono or unidentate ligand. Then we second classification is poly or multidentate ligand. Third one is amphidentate ligand. So we had seen what is monodentate or unidentate. The word itself tells you that mono or uni means one donor atom. Okay, so let me give you the definition of mono again. So mono or unidentate ligand. So a ligand in which, okay, it is bound to a metal ion through only a single donor atom. Okay, so only one donor atom if it is there. Okay, then such a ligand is called as what? They are called as monodentate or unidentate. Okay, they are termed as monodentate or unidentate. So here you can see water. Okay, H2O. So H2O. Okay, so only oxygen can bond to a metal. So such like, so here a molecule is present. So this is a ligand. Okay, this molecule, water is a ligand. So which is the point of attachment? Your oxygen. So only the oxygen atom. So there is only one point of attachment or only one donor atom present in this molecule, and this can coordinate with the central metal atom. Then such molecules are called as, such ligands are called as monodentate, or they are called as unidentate ligands. Okay, they are termed as monodentate or unidentate ligands. Fine. So here, so we had discussed some of the examples in our previous class. Okay, so the examples for the negatively charged and neutral ligands. So let me give you again. So neutral ligands, okay, and negatively charged ligands. Please note this down, very important. Okay, you need to know this all. So for neutral ligands are your amine, okay, amine, your NH3. So your nitrogen has that attached. Okay, nitrogen will get attached. So it is a donor atom. Then next is your aqua. So in aqua, H2O. Okay, so oxygen is the donor atom. Then is your carbonyl. Okay, in carbonyl, carbon and oxygen. Again, the carbon is the donor atom. Then is nitrosyl. Nitrosyl, that is NO. So your nitrogen is the donor atom. Next is your pyridyl. Pyridyl. So C5, C6H, C6H5N. So here nitrogen again is the donor atom. So the point of attachment here is only one point of attachment is there. So they are termed as mono or unidentate. So let me write here the negatively charged cyano. Cyano, that is Cn minus. So here, okay, your carbon is the, then hydroxo, okay, that is OH minus. So oxygen is your donor atom. Then is your thiocyanato. Thiocyanato is SCN minus. So your S is the donor atom. Then is your halo, okay, X again. Then nitro, NO2 minus, so your nitro group, and oxo is your O2 2 minus. Okay, so this is the these are the examples of your monodentate ligand. Is it clear? So what is monodentate ligand? So ligands means what? They have the capacity to give electrons. Okay, they can donate electron to the central metal atom. Now here we are discussing about the types of ligands. So first is monodentate or unidentate ligand. So here only one donor atom is present. Okay, and one point of attachment. Okay, so by only one point it can attach to the central metal atom. So such molecules or ions, they are termed as monodentate or unidentate ligand. Is it clear about mono and unidentate ligands? Yes, okay, fine. So let us go for the next ligand, next type, that is polydentate or multidentate ligand. So poly means what? Many, right? Poly means what? Poly means many. Okay, poly means many. So a ligand in which a metal, okay, a ligand in which, okay, ligand uh, which is bonded, okay, which is bonded to a metal ion through two or more sides, okay, two or more donor atoms. So when you have more than two or more donor atoms, okay, if it is present in the molecule, then they are termed as what? Polydentate. So if you have more than, if it is two or more, so from two to you can say six. So if you have in this, so again it is classified as what? So if you have two donor atoms in a molecule, then they are called as bidentate. If you have three donor atoms in a molecule, then it is called as tridentate. If you have four, then it is called as tetradentate. Okay, so depending upon the type of donor atom, so this is the classification. So tetradentate, then if you have five, then it is called as pentadentate. If it is six, then it is hexadentate. Okay, so in the previous class, we have seen that these all are bidentate because you can see in the oxalate, ethylene diamide, diacetyl, dioxanine, okay, 2,2-dipyridyl and acetacetonate. Okay, so here you can see in each case what you can see that the sites are only two. So in the full molecule, you can see there are two donor atoms, right? So these are all what type of ligand? These are all examples of bidentate ligand. Okay, these are all examples of bidentate ligand. So let us see now each this. Okay, so let me take a plain slide and explain you. Fine. So let me explain you. So let us start with what? So let us start with the bidentate ligand. Okay, let us start with the bidentate ligand. So what is a polydentate? So second classification is polydentate ligand. Polydentate ligand. Okay, so a ligand which is bound to a metal atom through two or more donor atoms. Okay, simultaneously. So simultaneously, the word is important. So at the same time, all the two or more donor atoms will join. So these are firstly classified as what? First, let us see is the bidentate ligands. Okay, let us see bidentate ligands. Okay. So what is bidentate ligand? So bidentate means what? A ligand which is bound to a metal atom through two donor side. Okay, to two donor atom. Okay, simultaneously is called as bidentate ligand. So a ligand which is bound to metal ion through two donor atom, then it is termed as what? What? It is termed as bidentate ligand. So let us see example. So please write down these examples. Very important. Okay, very important. So what is the name? So here our donor atom is your nitrogen. Okay, so through nitrogen at the same time it can bond. So this is ethylene diamine. This is ethylene diamine. Okay, ethylene diamine. That is, it is represented as En. Okay, it is represented as En. Suppose like this. Like this. Got it? So like this, the metal is linked. Okay, so like this, your ligand is linked. So this can be the example. So in the center, metal is there, and through two, so ethylene diamine. Okay, ethylene diamine, like this, it is represented. Got it? Okay, so this was the first example, ethylene diamine. Second is diethyl glyoxime. Okay, diethyl glyoxime. So let me write it, CH3. C double bond N OH. So your nitrogen. Again CH3 C double bond N OH. Okay. So here the nitrogen. Okay. So this is your dimethyl glyoxide. Okay, that is DMG. So diethyl glycine. So from nitrogen at these two sides, you can see it will link to the metal atom. So this is the second example. Okay, this is the second example. So let us see the third one. So third example of bidentate ligands. So please note down these examples, very important. Then CH2, C double bond O. Okay, then O minus and NH2. So your nitrogen. So here also, so this is glycolate. Okay, glycinate, sorry, glycinate ion. So it is represented by GLY. Okay, GLY. So glycolate ion. So here the two sides are nitrogen and here your oxygen. So from these two sides, the I don't. So these are the two donor atoms present in this particular molecule. So these at the same time, it will get bound to the central metal atom. Then the last one. Okay, so from this two nitrogen atom, so it is 2 dash by pyridyl. Okay, so it is BPY. Like this, it is represented. So these are the four examples of a bidentate ligands. Okay, so you can see at the same time from this particular, okay, so these are the donor atoms which will get attached or they will get linked to the what central metal atom. Next is tridentate ligand. Okay, tridentate ligands. So what are we going to discuss in tridentate ligands? So a ligands in which there are three donor atoms. Okay, they are having three donor atoms and they form three coordinate bond. Right, they will form three coordinate bond with the central metal ion is called as tridentate ligand. Right. So metal is there, and from the same ligand, you have three donor atoms. So they will form what type of bond? They will form a coordinate bond between these. Okay, so there is only one ligand. So in the one ligand itself, what will happen? Three donor atoms are there. Okay, so this is called as tridentate ligand. So one more time, I'll repeat the ligand having three donor atoms, and hence, okay, they form three coordinate bonds with the central metal ion will be called as tridentate ligand. So let me write the examples. So your three donor atoms are present. So let me write the example. So first one, first example. So example first one. So it is ethylene, diethylene, triamine. Okay, diethylene, triamine. Okay. Hmm. So let me write the structure. So CH2, NH, CH2, CH2, NH2, CH2, NH2. So this is first donor atom, here one, like this, and like this. So this is ethylene diamine, DIEN. Okay, diethylene triamine. So there are three donor atoms at the one side. I hope you are writing down the structures. Okay, so you can see at the same time from this three donor atom, it will get bonded to the central metal atom and it will form what? Three coordinate bonds. Okay, so this was a example for tridentate ligand. So let us see next word, tetradentate ligand. Tetra. Tetra means what? Tetra means what? The ligand having four donor atoms. Okay, the ligand having four donor atoms and it forms four coordinate bond with the central metal ion. Okay, so example is triethylene, triethylene tetraamine, triethylene tetraamine. So let me write the structure here. So NH2, okay, CH2, CH2, then NH, CH2, CH2, NH, then CH2, 1, 2, 3, and 4. Okay. So which are the four donor sides? So 1, 2, 3, 4. Okay. So in the same molecule, okay, in the same molecule, what you have? Four donor sides. Okay, you have four donor sides. So these, what is the name? Triethylene, triethylene tetraamine. Okay, triethylene tetraamine. Is it clear? Is it clear? So what is bidentate, what is tridentate, and what is tetradentate? Is it clear up to here?
Yes, ma'am.
Okay. So please note down the structures. Okay, examples for a bidentate. What is example of tridentate and what is example of tetradentate ligands? Okay. So let me clear this. So next is what? Next is your okay. Next is your pentadentate. Pentadentate ligands. Pentadentate ligand. Okay. Now what is the definition of pentadentate ligands? Yes, pentadentate ligands. So the ligands having five donor atoms. Okay, the ligands having five donor atoms and it forms five coordinate bonds with the central metal ion is called as a pentadentate ligand. So the example is ethylene, ethylene diamine, diamine triacetate, triacetate ion. Okay, so it is EDTA. It is called as EDTA. Fine. So what is the name? Pentadentate ligands. So in this, the ligand is having five donor atoms and it forms five coordinate bonds with the central metal ion is called as a pentadentate ligand. So the example is ethylene diamine triacetate ion. Okay, EDTA. So let me write the structure now. COH, CH2, NH2, CH2, CH2, then N, CH2, 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 C double bond, O minus, and here CH2, C double bond O, O minus. Okay. So here, how many sides should be there? There should be 5 sides. Okay. So 1, 2, 3, then 4, and here 1, 5. So yes. So I'll mark the sides. So 1, okay. Then 2, then 3, 4, and this one is 5. Okay, so like this. So there are how many? 5. Okay, so 3 oxygen atoms. Okay, 3 oxygen atoms uh, and 2 NH. So from this, what will happen? So 2 nitrogen atoms. So this is a 5 donor sites. So like this, the metal ion will get linked, okay, to the 5 donor sites of the ligands. So this is a example. So EDTA, okay, EDTA, okay. Next is hexadentate, hexadentate ligands. Next is hexadentate ligands. So again, what will be the definition? The ligands having 6 donor atoms. Okay, it has 6 donor atoms and it forms 6 coordinate bonds with the central metal ion. It is termed as hexadentate ligands. It is termed as what? Hexadentate ligand. So let me write the example: ethylene diamine, ethylene diamine tetraacetate ion. So this was triacetate, this is tetraacetate. Tetra means 4 acetate ions. Here you can see there are 3 acetate ions. Okay. So this is 1 acetate, this is another acetate, and this is 3. Okay. So there are 3 acetate ions. Here there will be 4 tetra. So let me write the structure now. So it will take more space. So let me write in the structure. So CH2, CH2. Okay, then here one N, let me take it down. So CH2, CH2. Okay, here N, here one N. So then again CH2, then C, double bond O, O minus, then here N CH2, C double bond O, O. Okay, like this. Then CH2, C double bond O, O minus, and CH2, C double bond O, O minus. Okay. So just see the sides. Just see the sides. So this is one, this is second, this is third, and fourth, fifth, and sixth. Got it? So this is what is the name? The ethylene diamine tetraacetate ion. That is EDTA minus 4. Is it clear? So, is it clear about the classification of ligands, types of ligands? So, we have seen monodentate and we have seen polydentate. In polydentate, we have seen bidentate, tridentate, tetradentate, hexadentate, pentadentate, and hexadentate. Is it clear up to here? Yes. Is it clear up to here? So, we have seen the ligands. Yes. So, please note down the structures. Please note down the structures. Okay. So let us go for the next one. So next is the chelating ligands. Okay, next we are going to discuss about the chelating ligands. Chelating, chelating ligands. Okay, so what do you mean by chelating ligands? A bidentate or a polydentate ligand, okay, a bidentate, so more than one, that is maybe two or more. So whenever you have bidentate or whenever you have a polydentate ligands, okay. So whenever you have bidentate or polydentate ligand, so what will happen? This ligand, it will attach to the same metal atom, right? With two or more donor atoms. So that time it forms a ring structure. It forms what? Ring structure. So bidentate or polydentate ligand, which which can attach, okay, which can attach to the same which can attach to the same central metal ion, which can attach to the same central metal ion with two or more donor atoms, okay, two or more donor atom forming forming a ring structure, forming a ring structure. It is called as what? Chelating this what ligand. So example, if I give an example, so all the examples that is in bidentate ligands, okay. So when they are attaching to the your central metal ion, what will happen? Suppose I take ethylene diamine. Okay, ethylene diamine is our ligand. So copper, let me take copper as a central atom, and our ethylene diamine is what? CH2, CH2, okay, and NH2. So like this, it will get linked, okay. Then again, ethylene diamine. So NH2, CH2, CH2, NH2. Sorry, this should be your, so H2N, and this will be linking. Okay, so this is forming what? This is forming your ring-like structure. You can see ring-like structure, like this ring it is forming. Okay, it is forming ring-like structure, right? So this is, it is forming what? Ring. So this is your, so whenever you have bidentate or polydentate ligands, okay, which can attach to the same central atom, so only one central atom is present, okay, with two or more donor atoms. So this is one bidentate ligand and this is another bidentate. I had shown you, right? So metal and ethylene diamine and ethylene diamine. So you can see ring-like structure, right? So the same way I have written. So whenever in a particular ligand, okay, if you have a bidentate or polydentate and if it is attaching to the same central atom, so it will form a ring-like structure, and such ligands are called as what? Chelating ligands, okay? So the number of such chelating ligands or groups are called as density of ligands, okay, which can form structure, which can form ring-like structure. They are called as what? Density, okay, density of ligand. So this is about your chelating ligand. So this is about what? Chelating ligand. Is it clear? Is it clear about chelating ligands?
Yes, ma'am.
Okay. So next is your amphidentate ligands. Okay, next we are going to discuss about amphidentate ligands. Okay. Next is amphidentate ligands. So what all we have discussed in ligands? Monodentate ligands. Okay. So in monodentate only one. Okay, it has one donor site. Second one we have seen polydentate. In poly we have seen from 2 to 6. Okay. 2, 3, 4, 5, and 6. Then we have seen chelating ligands. What are chelating ligands? So the when you have two or more that is donor atoms, when it is linking to the same central metal ion, it forms ring-like structures. Such ligands are called as chelating ligands. Then now we are discussing about amphidentate ligands. Okay, amphidentate ligands. Now, what are these amphidentate ligands? So, when in the same molecule, when you have more than one donor atom, okay, if you have more than one donor atom, but it will coordinate to only the central metal atom to only one metal ion, okay, or one donor atom, then it is called as amphidentate ligand. Then it is called as what? Amphidentate ligand. Suppose for example, okay, CN is there. So CN, it can coordinate to what? It can coordinate to carbon also. So if it coordinates through carbon to the central metal atom, then it forms cyano group. Then it forms cyano group. If the nitrogen atom links to your central metal atom. Okay, so what it forms? It forms the isocyano groups. It forms what? Isocyano group. Remember that. Okay, so here both. So here, what is amphidentate ligand? So it's a molecule in which both the if there are two or more donor atoms, but only one donor atom will get attached to the central metal ion. So such ligands are called as what? Amphidentate ligands. One more example. So this is the best example for an amphidentate ligand. Remember that. So cyano group. So if it links to carbon, it forms cyano. Okay, to the central metal atom. And if it links to nitrogen, okay, to the central metal atom, then it forms isocyane. Okay, isocyanides. You know this, right? So this you have to remember. One more example I'll give you. So please remember this example. Important, they will ask you what is amphidentate ligand, give examples. Important, very important. Amphidentate ligand, so please remember that. So in a same ligand, when you have two or more donor atoms, but only one donor atom will get attached to the central metal atom, is called as the amphidentate ligands. Okay, now one more example is your nitro group. Okay, nitro group. So NO2, so when nitrogen atom will get linked to the central metal atom. Okay, so it forms nitro group. It forms what? Nitro group. Then if oxygen of the nitrogen, okay, nitro group, if it get linked to the central metal atom, then it forms what? Nitrito group. It forms nitrito. It forms what? Nitrito. So O minus N double bond O, like this. So when this attached to the central metal atom, it forms nitrito. Okay, nitrito. Is it clear? So nitro group. So in nitro group, both the nitrogen as well as oxygen can coordinate. Okay, if it coordinates from nitrogen, it will form nitro group. If it coordinates from oxygen, then it is forming what? Nitrito. It forms nitrito. Is it clear? So these are amphidentate ligands. So a ligand in which contains more than one donor atoms but coordinates with the central metal ion by using only one donor atom is called as amphidentate ligands. Is it clear? So we have seen one example of cyano, one example of nitro. One more example. One more example. Let me give you one more example. So please remember the examples, very important. Okay, example number 3. So when you have this group, what is this group? SCN minus thiocyanide group. Okay, thiocyanide group. So when you have thiocyanide group, it can coordinate from sulfur also and it can coordinate from nitrogen also. Okay, so if it coordinates from your sulfur, if it coordinates to your sulfur, okay, it forms what? Thiocyanate. Thiocyanato. Okay, thiocyanato and cyanato. And when it links to NCS, I'll write it here. That is when it links to your nitrogen NCS through your central metal atom, then it forms what? Isothiocyanato. Isocyanato. Okay, isothiocyanate. Is it clear? So these are the three examples. Is it clear? So write all these three examples. So first is the nitro group. In nitro group, both nitrogen and oxygen will get linked. If nitrogen will link, it will form nitro group. If oxygen will link, it forms nitrito. Then in Cn minus, okay, if carbon links to the central metal atom, it forms cyano. If nitrogen links to the central metal atom, it forms isocyane. Then the next last was SCN. Okay, if sulfur links to the central metal atom, it forms thiocyanato. If your nitrogen links to the central metal atom, it forms isothiocyanato. Is it clear? Everybody. So this is about the types of ligands. So depending upon these all types, we are going to apply it later. Okay, so how to write the coordination compounds and all. So that time we are, so if I tell you what is EN, EN means it is ethylene diamine. Okay, so like this you need to remember everything. Okay, ethylene, EN means what? Ethylene diamine, EDTA means what? Okay, EDTA is ethylene diamine tetraacetate ion. Okay, or triacetate ion. So like this. Okay, so this way you have to remember all the ligands. Okay. So next is coordination number. Next we are going to discuss is the coordination number. So next is your coordination number. So the coordination number of the central metal ion is a complex, can be defined as the number of ions. Okay. The number of, so the number of ligand atoms which are bonded directly to the central metal ion, it is called as the coordination number. Suppose I have FeCN6 minus 3. Can you tell me the coordination number of this? Yes. How many to the central metal ion? How many ligands are attached? 6, right? 6 ligands are attached. So you can represent this like this particular complex, you can represent it like this. And okay, so what it is the coordination number is 6. The coordinate, so the number of ligand atoms, okay, which are bonded directly to the central metal atom, it is called as the coordination number. Okay, let me see the next one. Let me take one more example. Okay, FeC2O4 3 minus 3. Okay, now here you should know that this is a oxalate ion. This is a oxalate ion, and oxalate ion, okay, like this it will be. So what is the here? So from both the ends, okay, it can coordinate, right? So how many oxalate ions are there? 3 oxalate ions are there. So if I write 3, now you have to tell me, okay, so 1, 2, and this is 3. Can you tell me the coordination number? So 2, 4, and 6. So the coordination number is 6 because it is a bidentate ligand. Okay, it is a bidentate ligand. So the coordination number is what? It is 6. So 3, we have taken 3 oxalate ions, but in each oxalate ion, there are 2 donor atoms. Okay, 2 donor atom. So it is a, okay. Then we see this one, AgCN2 minus. Yes. What is the coordination number, students?
2.
Yes, 2. Very good. So the coordination number is 2. Next one, if I give you copper NH3 4 plus 2. Yes. What is the coordination number? It is 4.
4.
Very good. Yes. Next one. What is the coordination number?
4.
4. Yes. Then CO. Okay. This one. Think and tell.
3.
No. Ethylene diamine is what? It is a ethylene diamine. It is a, this is what? It is a bidentate ligand, right? It is a bidentate ligand. So each ligand, it will have what? It will have 2 donor atom. Okay, so like this. So because of that, you need to remember these. Okay, so each ethylene diamine, okay, they have 2 sides. It will attach. So how much they are? Just see now, count. So it is 1, 2, 3, 4, 5, 6.
6.
So 3, yes, so it is 6. So ethylene diamine is what? It is 6. So what is coordination number? the number of ligand atoms which is bond directly to the central metal ion in the complex. Okay, so coordination number, it is determined by only sigma bonds, okay, which is formed by the ligands and not by the pi bond. So this like this, okay, only the metal and ligand bonds, okay, which is represented by the sigma. Okay, so only these are counted, not the pi bonds. Now, suppose if you have a coordination number two, if you have coordination number two, so then you will have a linear molecule. Okay, so metal will be in the center and two ligands. So which example we have seen? AgCN minus. So AgCN and AgCN like this. So this is a linear molecule. Okay, this is a linear molecule. So whenever, so remember when you have coordination number two means what? Your metal is there and it is linked to two ligands. Okay, so it is a linear molecule. Okay, 180-degree angle. Then, if you have a coordination number four, if you have coordination number four, it can form two, this what? It can form two arrangement. One is the tetrahedral arrangement. One is the tetrahedral arrangement. So this is the tetrahedral arrangement. And another is the square planar arrangement. Okay, square planar arrangement. I can write it like this. Don't want like this. Wait. So metal in the center and four ligands at the four corners. So this is the your square planar. So this is the geometry when you have Cn is equals to 4. Okay, metal and it is linked to four ligands. Okay, if you have geometry number 5, okay, when you have geometry number 5, so let me clear this. So when you have geometry number that is Cn is equals to 5, so metal will be in the center. Okay, so these are the three ligands here. So this is what? And here 2. Okay, so this is termed as what? It is termed as trigonal. So you can see a triangle at the base. Okay, and this is a bipyramidal. So bipyramidal. So like this. Okay. So what is this? Trigonal bipyramidal. So triangle here and these are the two bipyramidals. So this is coordination 5. So this is what name? Trigonal bipyramidal. Okay. One more with coordination number 5 is your square planar complex. Okay. That is a square bipyramidal. Okay, square bipyramidal. So metal in the center, then four ligands at four corners. Okay, and bipyramidal means what? So again, we will join this just a second. So like this. So this is your square. Okay, and here will be your again two ligands. So square bipyramidal. Sorry, square pyramidal, not so this is your square pyramidal. Okay, I'm drawing square pyramidal. Square pyramidal means centrally one metal and your your four. So four bonds are already formed. Okay, between the metal and ligand. Now we are left with only one. So this is your that one ligand. Okay, so how it will form? So this metal, this ligand, it will get, okay, it will be attached to all the four corners like this. So there are how many ligands? There are 5 ligands. So it is a square pyramidal, square pyramidal. Okay, because bipyramidal means two up and below. Now, when you have coordination number 6, when you have coordination number 6, okay, I'll show you in the central metal. In the central metal is there. Central metal is there. Then 1, 2, 3, 4, and 5 and 6. Okay, so let me join this now. So, okay, so you're like this. Fine. Now, so these are the bonds, right? So we'll write bonds like this. Now we will draw the, So this is the octahedral geometry. So this is octahedral. So the metal is in the center and 6 ligands are present across the metal. Is it clear? Is it clear what is coordination number and what is the geometry related to the coordination number? So when you have two, it is linear geometry. When you have four, two type of geometry can occur, tetrahedral and square planar. If you have coordination number five, two, it is again trigonal, bipyramidal and square pyramid. And when you have coordination number six, you have octahedral. So you need to know all this geometry. Okay, is it clear up to here? Yes. So next we are going to see coordination sphere. Okay, how to write that complex. Then then homoleptic and heteroleptic. So this all things we will study in the next class. Okay, followed by the nomenclature of coordination compound. Any doubt in today's session? Any doubts in today's session? Yes, so we have discussed the types of ligands. Okay, types of ligands, polydentate ligands, all the types we have discussed. Chelating ligands we have discussed. Amphidentate ligands we have discussed. Then we have discussed about coordination number and the geometry of the coordination. This. Okay. Fine. So by this, we shall end the session here. Okay. So the remaining things we will be discussing in tomorrow's class. We'll discuss how to write the complex. Okay. And then we'll discuss how to name the complex. That is nomenclature. Fine. So by this, I'll end the session here. Okay. We'll meet in tomorrow's class. Thank you. Have a good day.